Hi, good morning, good afternoon, and good evening, everybody. And today we'll discuss about the we left with few topics yesterday, and today we'll continue with that. So let's do a fragmentation lab now. Yeah, we did only the PCAP, and we learned about the parameters of fragmentation yesterday, and today we'll do a lab. Let me share my screen for it. Let me log in my PC. So let me quickly configure the IPs. We'll just do a direct connect, and there's a problem with the Wireshark with the other computer. So I had to change this. So if you look at this, this is the IP, the IP connection I'm going to establish between the devices. So I'm on R1. So this is the subnet I'm going to use for direct connect between R1 and R2. So I'm going to use 10.0.0 subnet. In the meantime, I forgot one thing. I will mute everyone. So I'm going to establish a connection to R2. So I'm on Ethernet 0/1 and it goes to Ethernet 0/0 on R2. So I'm going to configure it with an IP address there. IP address 10.0.0.1 on one end. So interface Ethernet 0/0, IP address 10.0.0.2/24 255.255.255.0. Let me try to ping the directly connected device, the R1. I can ping. So let me change the MTU on this. Let me take a quickly this. One second. I'm just fixing something here. Okay, so let me configure the MTU here, right over here. It changes. So let me take an MTU of 1200, same 1200 over here. I'm going to interface Ethernet 0/0. IP MTU. I'm making it as 1200. Show run interface Ethernet 0/0. So the MTU is 1200 here. I'm going to R1. I'm going to do a capture here. I'm going to the R2 and I'm going to capture on Ethernet 0/0 to see actually the fragmentation is happening on the destination. So I'm on R1 now. Let me try to ping. I want to see the traffic is going through the link. Let me add this as a column, identification number, and to show you something about that. So somebody asked me a question yesterday. I mean, what is the IP ID related to the fragmentation? Let me stop this capture. So when you click on this, you can see two arrows in the Wireshark. It shows you the ping request and the ping reply back. So there's a first packet. The ping packet goes from the 10001, the source, to the destination 10002. And you can see the arrow mark which points to yours. I mean, this is going to forward direction and it is a backward direction, right? So if you see these two packets, so you will come to know that this forward arrow indicates that it's a ping request going out from the device from this source 10001, and the reply I got it from 10002. So how do you find this helps you to find latencies. If you actually see this particular packet exactly at 955 milliseconds. Let me take this epic pen to annotate something here. So this is the time taken, right? This is milliseconds. So it took 955 milliseconds to send this packet back, and you got a reply back in 396 milliseconds from 10002 to 10001. It's in reverse direction. And if you see the the identification number, it helps you to find the packets, right? It's like stamping your packet. So your first packet goes out with the identification number, all zeros, you can see. And this particular packet, it goes with 001. So this shows me that this is the first ICMP packet and this is the second ICMP packet. Ping request, I got a ping reply, and this is my second ping request. For the second ping request, I got a ping reply back from the destination. If you see, it keeps incrementing, right? 3, 4. So totally I sent 4 ICMP packets and I got 4 ICMP packets back. So I'm not missing any ICMP packets. So this helps locally inside the LAN to figure out, is it my any ICMP packets is being dropped in the middle or it's being blocked. So the identification number is something you can use it to troubleshoot when you are doing an ICMP, when you do a continuous pings, and you can see where exactly you are losing your packet. That gives you a more granular way of troubleshooting when you're doing with an ICMP related troubleshooting. It helps you for that. So that's different from the fragmentation. So when we are coming back to the fragmentation now. So since I said it's a directly connected, and we change this MTU here to 1250 here on R2 Ethernet 0/0. And now let's use extended ping. That's something we can use in the routers to test your connection. So for that, let me do a ping. The protocol is IP, right? And I'll tell you one more thing here. What's happening? So IP interface brief. Load unassign. Config interface. The net 0/1. So I'm going to this particular interface on R1, Ethernet 0/1. And if I give shutdown, manually admin down, Ethernet 0/1 and no IP address. Okay. So when you don't have an IP address on a box, it's a brand new box, or it can be because of some problem. Actually, this is something. So I haven't configured any IP address on this box. So this R1 doesn't have any IP, and there's no routing happening here. And when we try to do a ping, it says an unknown protocol. So it's something you can look at your devices as your device is actually doing any kind of routing. Is it any interfaces or up? Because it is telling that it's an unknown protocol for ping because we are not doing any routing there. We're going to Ethernet 0/1. We're going to assign an IP address. IP address 10.0.0.1, 255, 255, 255.0. Oh shit. So IPR. Ping 10.0.0.2. Now I'm going to use an extended ping. Ping, the protocol is IP. Target IP is 10.0.0.2. I'm from R1. 10.0.0.2 is the IP address assigned on R2. The input count is default. Datagram size, I'm going to give 1800. Time in seconds, default. I want to use an extended commands. Yeah, yes. Ingress ping, no, I'm not doing ingress ping. Source address 10.0.0.1. Anyways, if you have a one IP address, it doesn't have any other option. Always it picks your source address as your leaving interface. IP address will be your source address in any time when it talks to the destination. So it depends. So here you got two interfaces here. So if you have a WAN connection to this box and you don't have a direct connection between the, how do you say, I mean, from R1, if you want to reach R3, then if you don't define any IP address, so it's going to define it's going to pick this Ethernet 0/0, since that's the only way it can reach R3. So when you're doing some kind of troubleshooting with traceroute or something, you should know how the device picks the source address. So by default, it picks the leaving interface and depends on the connection what you have. Inside your routing table, you have a route for 11 network, right? So and you have this directly connected interface Ethernet 0/0. So obviously it's going to pick this IP address, the range, this IP as a source to reach R3. But since this we got only one interface is up and running, even though if you don't define this, it's going to pick 10.0.0.1. Even when the packet forwarding is happening between devices, even from your firewall, your load balancer, it's uh, it's very important to understand that how it picks a source address. So I'm not using any DHCP values. I'm not using any QoS. I want to set the do not fragment bit in the IP header. Yes, I'm going to set that in my IP header. So I'm not going to validate the data. Everything is the default. Now let's see the PCAP, what we see there. Here it is actually stopped with 100%. So I have to start this again. And R2 going to the capture, I'm going to capture the traffic on Ethernet 0/0 because the traffic comes in on Ethernet 0/0 from Ethernet 0/1 on R1. Going back to R1, trying to do the same process again. 10.0.0.2 going to R2. Datagram size is 1800. Extended ping. Source interface, I'm not giving anything here. It's going to pick 10001, DF bit yes, all default. Okay, I don't see any traffic there. I try to ping 10002. I can see the ping packet, but when I do this, not happening. So let's do it in the reverse direction. Let's do from source. In 002, 1500. Everything is default. So let me stop this capture. So what's happening here? We are sending this 1500 bytes of data. Yeah. And if I click on this guy, let me drag this up. It's a bit slow. Just bear with me. So you can see these two fragmented packets, and Wireshark will show you the with the dot right over there. So you can see the two packets are fragmented here. So the fragment count, it says 2, and we have sent 1500 bytes of data. It just fragmented to 1176 and 304. So it can't do it in one go because we set the MTU as 1200. So it has to do a fragmentation. So if you look at this, the fragmented packets over here, it's coming from 10002 to 10001. How do I confirm in the device? OIP traffic load fragmentation. So here R1, I don't see any fragmented packets in R1. So there are 5 fragmented packets here. So who is doing a fragmentation? The fragmentation is done by the router 2, 10.0.0.2. So this is something, it helps you when you do a packet capture, you have to look for this, the reassemble packets here. So here the reassembly happened here. 1, 2, 3, 4, 5. 5 times we see this reassembly, and we should see all the traffic, right? I mean, all your data payload. We have sent something about 1,500 bytes of data, and I should receive all the 1,500 bytes of data. So that's how you should understand your fragmentation. If there is some fragmentation is happening and we are troubleshooting something with that, and you have to look for all these options. And let me show you one more use case. So if you look at this, this is some kind of a UDP traffic sense. And if you click on this, you can see a dot right over there. When you follow this dots, 1, 2, 3, 4. So this is all fragmented packets. You can find it there. And your payload here, it's totally, they have sent 5,387 bytes of data, and it's been fragmented into 4 pieces, and it reassembles. This is one common UDP traffic that goes, but UDP is the upper layer protocol in the OSI. When it pushes down to the lower layer protocol, layer 3, it can't, it cannot push the 5,387 bytes of data in one go, so it fragments the data. So this is how it works with multiple protocols. You can find if the fragmentation, if you see some, if you're doing some packet analysis, you can figure out, is it the number of packets, the payload, whatever I have sent, is it properly being delivered successfully there? Right over here, you can see all your fragmented packets. As I said, if you calculate, you will get the whole data what you have sent. And also you can make use of this field. I generally use this, the length field here. It gives you the number of payload, 5,379. So you can go to the corner of this capture and you can see the length of the packet. So and if you see this particular packet, what we are looking at here, the option to mark the packet. So now I mark this particular packet, right? If you go right click and do a marking, it marks with blue color there. So if you calculate this data, 5,379 bytes of data, you see right over here, from here, it's been fragmented and reassembled right over here. And you get all the data, the payload that's been fragmented. So yeah, this is a use case for the fragmentation. So when you do troubleshooting, when there is some fragmentation issues, and if you're missing out some data, maybe, right? I mean, if the device is not capable of doing a proper fragmentation, and if your MTU value is too low, you can go ahead and tell them why this particular device has an MTU got a very less MTU for it. Is it any specific reason for it? So the data is being fragmented a lot, and I see a latency. So I have seen such problems with the fragmentation. If the MTU is very less, somewhere around 1,100 you might experience a problem when you're pushing a large amount of data. So that's a takeaway of this fragmentation lab. Let me put up this. So next, let's jump into the topics we have. We did this PMTU. So now we are going to do some different TTL scenarios here. So TTL has, as I said, the TTL should always have a value. Let me open up a PowerPoint very quickly. Here's my PowerPoint. So far, we covered, the version we know, we are using IP version 4, and the total length of the packet we have seen. And I'll show you the fragment offset there. Source address, destination address, and IP option is something we are going to do now. And the one more important field I said for troubleshooting is your TTL. And identification. Identification number, I have shown you how do you find your IP identification. So we covered the most important IP header parameters. What should we look and concentrate when we are troubleshooting your IP header parameters? So now let me show you what is a fragment offset. So here, if you see this, the flags, you see that there is a fragmentation. Whenever you see this particular flag in right over in your IP v4 header, so right below that, if you see this fragmentation flag set, so if it is all zeros, right? If you go for anything with zeros, so here if you see zeros, right? So there is no fragmentation happening here. But if I go here, there is a fragmentation happening. Where? In 10002, not in 10001. So from this fragment flags, you can figure out who is doing fragmentation. So here 10001 is not doing a fragmentation. So 10002 is doing a fragmentation because it sets this value. If you see the source IP address here, it is 10002. So each sets a fragmentation because that guy is doing a fragmentation because it doesn't have an default MTU. We just purposely we reduce the MTU size. So he is doing a fragmentation. So all these fields are helpful when you troubleshoot, when you're analyzing a package, when you look through your eyes, you should look at all these options, the very important options, what we discussed here. You have to look for your TTL, you have to look for your fragmentation flags. So this is called a offset, fragment offset values. So we are sending a data here, right? So we send a data of 1480 bytes of data. The fragment offset starts with 02175 frame 18. Yeah. If you look at this is the fragment offset values, it's 18. So out of 1500 bytes of data, this offset carries 1176 bytes of data. And the second offset 19 carries 304. So this helps you to figure out if there is some packets missing in the middle. Say, for example, you have sent 1500 bytes of data, and if you don't see a frame set offset value, something is a 19 missing. And if you receive 1176, there could be some problem with the latency, there could be some problem with something else, and but why we are missing it, that's something we can look when you do a capture, and you can figure out, and you can do your troubleshooting where you can look for either this particular device CPU spike too high, and because of that it can do the fragmentation, or it's because of the latency it can't do a fragmentation. But the whole point is, when you are analyzing the packets, do you see all these packets has been properly arrived to the destination? So that's really about the fragmentation.